Take a look at this new insane image by James Webb. What were you doing on July 12, 2022? Some may have been at home relaxing, immersed in their own activities, or playing video games with pals. Others may have been suffering from a broken heart, while others may have found solace in the tranquility of nature. And then there were those unhappy folks who were stuck in a never-ending cycle of labor. Nobody could have predicted that this seemingly routine day would hold anything truly extraordinary. On this fateful day, the most powerful telescope ever to grace the heavens was launched into orbit, ushering in a new era. Fast forward a year, and we're gathered here today to commemorate its first birthday. Excitingly, this beautiful equipment has a unique gift for humanity, an image that will leave you speechless. Prepare to be amazed by what could be the most gorgeous image of the month. Join me on this captivating video tour as we feast our eyes on this magnificent scene. It is an occasion that exemplifies the overwhelming genius of our creativity and our relentless quest to solve the universe's mysteries. The image. So here's the picture. Where do we even begin with this? It's mind-boggling how much is going on here. At first sight, you'll see a lot of red and these beautiful hexagonal lights that like spiky stars. And you are entirely correct, that is exactly what they are. But if you look closely, you'll notice there's a lot more going on. First and foremost, take a look at those extremely dark clouds. They appear to be quite intense, don't they? Here's the insane part. One of those clouds is punctured by a big torrent of crimson material. It's bursting out from within the cloud like a boss. Furthermore, the stream's edges are all dazzling and glowing. How cool is that? Let's break it down now so we can properly comprehend what we're looking at. It's like we're working on a puzzle together. A complete world condensed into a single frame. The cloud compound. First and foremost, let me to inform you the following: James Webb is never dull. It knows precisely where to look. In this occasion, the Ophiuchi cloud complex, the nearest star-forming zone to Earth, is the subject of this lovely cosmic artwork. It's like going to the nursery and seeing all these lovely tiny infants playing and crying, knowing that one day they'll grow up and become men and women with various stories, different eye colors, and different scars. The Ophiuchi cloud complex is named for the star that dominates the region, Ophiuchi, which is located 3 grades north of Antares in the Ophiuchus constellation. It is only 130 parsecs or 420 light-years away on average. The cloud complex appears to be separated into 2 primary clouds, denoted by the letters LDN 1688, which represents the principal nucleus, and LDN 1689, which has a lower mass. Many dark nebulous filaments connect both clouds. Because of its proximity, this cloud is an attractive field of study for low-mass stars and brown dwarfs, as well as a laboratory for studying chain star formation events. The circumstellar disks and the stars. We can plainly detect tremendous jets bursting out from newborn stars in the Webb telescope's close-up photograph. When these jets collide with the surrounding molecular hydrogen, it lights up and appears as red gas. What's more intriguing is that several of the stars in the image have a definite shadow around them, indicating the presence of a circumstellar disk. These disks serve as the foundation for future planetary systems. The young stars at the heart of these disks are around the size of our Sun, if not smaller. The most massive star in this photograph, however, is designated as S1. S1 can be observed in the image's lower half, surrounded by a shimmering cave-like structure. The powerful winds from S1 are literally carving out this structure. These winds are so powerful that they are forming a distinct shape in the surrounding gas. Polycyclic aromatic hydrocarbons make up the lighter-colored gas surrounding S1. These are carbon-based compounds that are abundant in space. They are required for the development of new stars and planets. When it comes to circumstellar disks, where can you find them? For example, focus on the top center of the image. There is a star with a big vertically squeezed dark shadow. It has a circumstellar disk. But what is it exactly? Remember that stars are made out of dust and gas. Following the formation of a star, the residual dust and gas are held in orbit, forming a spinning disk or donut shape around the young star. These circumstellar disks orbiting young stars are referred to as protoplanetary disks because they serve as a store of materials from which new planets can originate. In other words, this image is indicating that new planets may be developing in the Rho-Ophiuchi complex. Protoplanetary disks are believed to be 99% gas and 1% dust. Circumstellar disks change as planets originate and stellar systems evolve. Dust, gas, asteroids, comets, planets, and other debris may be found in circumstellar disks around older stars. The asteroid belt, Kuiper belt, and Oort cloud are all circumstellar disks around our Sun. The stellar jets. An intriguing phenomenon known as stellar jets occurs in the early stages of a star's life. These jets are portrayed in the right section of the image as a red jet of material issuing from a dark cloud. But what are stellar jets and how are they created? To comprehend stellar jets, we must first comprehend the concept of circumstellar disks. Circumstellar disks are flat structures of gas and dust that, like a spinning disk, surround a newborn star. These disks emerge as a result of the gravitational collapse of a molecular cloud and are critical in the formation of new planets. The material within these disks spins around the center protostar like a spinning top. Let us now investigate the mechanism of star jets. As material falls onto the protostar from the surrounding accretion disk, the interaction between the revolving stars and the disk's magnetic fields causes the material to shift direction. Rather than falling directly onto the protostar, some of this material is blasted from the stellar magnetic poles, resulting in the production of stellar jets. The accretion process onto the protostar, on the other hand, is not necessarily a smooth and continuous flow. The rate of material falling onto the protostar fluctuates erratically at times. Rapid increases in the accretion rate result in the development of denser bullets of material within the jets. This process enables scientists to directly quantify their velocity, providing significant insights into stellar jet dynamics. We can use an analogy to better comprehend this topic. Consider a spinning top with multicolored ribbons wrapped around its edges. The rotation of the top causes the ribbons to be drawn towards the center. If there are abrupt bursts of energy, the ribbons may fly forth in a jet-like fashion. Similarly, as material falls upon a newborn star from the surrounding disk, the interaction of magnetic fields causes part of the material to be ejected in the form of stellar jets. These jets are responsible for illuminating the molecular hydrogen in the area. It's as though when jet particles collide with hydrogen particles, the latter light up. In scientific words, molecular hydrogen emission is powered by a strong contact between the radio jet and the molecular gas. Galaxies hidden in the dust. This image becomes much more stunning when we examine its subtleties. Have you seen the features of these galaxies that we can see through the dust of the nebula? When told, it appears to be science fiction, but it is fact, a dream that is coming true before our eyes. But how does JWST accomplish this? One of the most amazing aspects of this telescope is its capacity to examine the universe in infrared wavelengths, allowing it to see through clouds that ordinary telescopes cannot. The advantage of seeing in the infrared spectrum is that the wavelengths of infrared light are longer than those of visible light. The JWST is able to see beyond these barriers by harnessing the power of infrared, exposing hidden marvels and disclosing hitherto unknown secrets of the universe. While the Hubble photos are already spectacular, they lack the ability to pierce the layers of obscuring debris. The story with James Webb, on the other hand, is rather different. Observations of the universe in infrared wavelengths give astronomers and scientists with a level of clarity previously only imaginable in science fiction. Saturn under a new light. As you might imagine, James Webb never ceases to amaze us. It only showed us Saturn in a completely different light a few weeks ago. The image depicted a very gloomy planet. This is because methane gas, which makes up Saturn, absorbs practically all of the sunlight that falls into the atmosphere at infrared wavelengths. The variances in appearance between the planet's northern and southern poles in this image are typical of Saturn's recognized seasonal fluctuations. Saturn, for example, is currently in northern midsummer, while the southern hemisphere is rising from winter darkness. The northern pole, however, appears exceptionally dark, possibly due to an unknown seasonal phenomenon impacting polar aerosols. Saturn is seen encircled by its famous system of rings, and the amount of detail is astounding. We can also see 3 of its moons on the left side of the image: Dione, Enceladus, and Tethys. In short, Webb's first year was unforgettable. Who knows what else this wonderful device will enable us to discover? We will of course keep you informed. Don't miss out on any of our new videos because the greatest is yet to come. Alright everyone, here's where the video ends. Thanks for watching. What do you think of this video? Let us know in the comments section below, and I'll see you on the channel again soon.